Hi, my name is Kate Berry from the University of Texas at Austin, and in this video I will demonstrate how we set up and solve total problems. Students solve total problems during Pirate Math Equation Quest during our multi-step word problem intervention with total, difference, change, and equal group schemas. The focus of this video is going to be on the total problems or the total schema. I will model and demonstrate how to solve 3 different types of total problems that students solve in our Pirate Math Equation Quest multi-step word problem intervention. So let's take a look. Here, when we're thinking about total problems and we're thinking about our multi-step word problem intervention, we have 5 different components of our intervention: captain cards, equation quest, Buccaneer problems, ship shape sorting, and our Jolly Roger review. And students are solving total problems during our Buccaneer problems, ship shape sorting, and our Jolly Roger review. But primarily, students are solving these total problems during the Buccaneer problems, so that is what I'm going to focus on within the context of this presentation. So to solve total problems, students are going to need a set of materials. First, they're going to need this large schema mat. We call this version 1 because you can see here we have only our total poster. They're also going to need the Buccaneer problem worksheet. And lastly, of course, they will need a pencil. So students always need their Buccaneer word problems and worksheet and a pencil. As students become more familiar with the schemas, you can actually start to fade out these posters. But initially, when we're introducing total problems, we want to make sure that we're using our large schema mat. So over the past 20 years, researchers have validated the use of schemas to help students solve word problems. In schema instruction, students are recognizing problems as belonging to a specific problem type. And developing these schemas for categorizing word problems proves more beneficial than other strategies. And so we want to make sure that in our intervention, we're helping students understand our schemas. For addition and subtraction problems, we use our total and difference schemas. And for multiplicative problems where we are multiplying or dividing, we will use our equal group schema. The change schema we also will use when we have additive schemas where we add and subtract. So let's take a look at our total problems, which again is the focus of this presentation. In total problems, we are putting parts together for a total. Students may solve total problems where the total is missing. Students also may solve total problems where one of the parts is missing, and students also may solve total problems that have more than 2 parts. In the slides that follow, I'm going to model how we would solve a total problem where our total is missing, a total problem where one of the parts is missing, and also a total problem with 3 parts. So let's get started. Here, we also want to make sure that students are gesturing as they are learning the schemas and thinking about what is missing. So for each word problem, schema, total, difference, change, and equal groups, we have a hand gesture. For total problems, we say our parts put together for a total. So we put our hands out and then move them together. Now, we do not say we put 2 parts together for a total because as we've just talked about, total problems can have more than 2 parts. So when we have the total gesture, students say our parts put together for a total. So let's take a look at a total problem where the total is missing. Here, we are going to go through our total poster as we work through each of these 3 word problem examples. So here, the student will write P1 plus P2 equals or is the same as T. That stands for part 1 plus part 2 is the same as the total. Then they will move to step 2. They find the total. The total might be missing, in which case we would put a blank, or the total could be known, in which case we would put a number. For step 3, the student would identify P1 and P2, part 1 or part 2. One of these might be unknown, in which case we would put a blank. For step 4, we write the signs. In total problems, our signs are always plus and equals, or plus and the same as. And then finally, we would find blank or solve for whatever is missing. So let's take a look at an example of a total problem with a missing total. So now let's practice setting up and solving a total problem with a missing total. Before I do anything, I need to check and see if there's a table or a graph. I don't see a table or a graph here. If there were a table or a graph, I would number it. But I don't see one, so I'm going to write my UPS check squared attack strategy letters on the side here. My first U stands for understand by reading. So let's go ahead and read our problem. It says Diego made 15 pepperoni pizzas and 28 mushroom pizzas. How many pizzas did Diego make? So I've read the problem, I understand it, I'm going to check off my first U. My second U right here says underline the label and cross out or check for any irrelevant information. Now, irrelevant information is going to be any numbers that are not related to our problem or what we're talking about. I like to check my question sentence that starts with a capital letter and ends with the question mark to see what my label is. It says, how many pizzas did Diego make? This story or word problem is talking about pizzas, so I'm going to underline pizzas as my label. Now I'm going to scan the problem and check my numbers and make sure they're also talking about or related to pizza. My first number is 15, that's about pepperoni pizzas. My second number is 28, that's about mushroom pizzas. So all of my numbers are related to our label. I don't have any irrelevant information. I can check off my U and move to my first P. My first P says parentheses needed numbers. This means I'm going to put parentheses around any numbers related to our label of pizzas. So my first number is 15. That's about pepperoni pizzas. We need that. So I'm going to put parentheses both around the number and the word what we're talking about. Our next number is 28. That's about mushroom pizzas. We need that. Now I have put parentheses around my needed numbers. I can check off my first P. My second P is to put numbers in order. Now in our multi-step word problem intervention, we expose students to single-step problems as well as multi-step problems that have 2 and even 3 steps. But in this word problem and for this presentation, we're focusing on single-step problems. So here we only have 1 step in the word problems, which means I'm going to put a 1 above our needed numbers. So here, I know I need pepperoni pizzas and I need mushroom pizzas. I know that those numbers are needed in my first step of solving the problem. I put a check mark next to my second P, and then I can move on to my first S, which stands for schemas. Right now, in this presentation, we're only talking about total problems. And in total problems, we know we put parts together for a total. I know this is a total problem because I have pepperoni pizza and mushroom pizza, and I'm putting those pizzas together for a total. We really want students, when they're talking about parts and total, to focus on the words and not the numbers. If they focus on the numbers, they're going to get really confused when they are presented with total problems that have a missing part. But here I know that I have a total problem because I have pepperoni pizzas and mushroom pizzas, and I'm putting those parts together for a total. So because I have a 1-step problem and I'm using the total schema, I'm going to put a 1-T on the side. I'm going to circle it to help me stay organized. So I'm going to check off my first S because I have found the schema. Now I can move on to my second S, which stands for solve. And to solve, I can just look at the total poster on my large schema map version 1. Here, my first step is to write our total equation. P1 plus P2 is the same as or equals T. Part 1 plus part 2 equals our total. Then I can move to step 2, find T. Sometimes we know our total, sometimes our total is missing. Here we know our parts, pepperoni pizzas and mushroom pizzas, but we don't know our total. So I'm going to put a blank underneath that T to identify our total is the missing information. Now I'm going to move to step 3, which is find P1 and P2. We said part 1 was pepperoni pizzas. I have 15 pepperoni pizzas. I'm going to check off that number so I know I've already used it. My other part is mushroom pizzas. I know I have 28 mushroom pizzas, so I'm going to put that under part 2 and check that off. Now I'm going to write my signs, which is step 4. In a total problem, our signs are always plus and equals or the same as. So I'm going to go ahead and write those. When we have numbers and students are not advanced enough to do the mental math, we want them to line up the numbers. I'm going to put the greater number on top. And I always say, draw the line, circle the signs. We're going to draw the line between the ones and tens columns, and we're going to circle the sign so that we remember that we are adding. I'm going to start in my ones column. 8 plus 5 is 13. So I'll put a 3 under the ones line and regroup. 2 plus 1 is 4. So I know my number answer is 43. But I'm not finished. We like to say that we want our numbers to feel supported and loved. We don't want our numbers to feel lonely. Every single word problem needs a number answer and a label answer. So I like to put a blank to help students remember that we have to add our label. All we need to do to find our label is to look in our question sentence and see that we've underlined pizzas. So I'm going to write pizzas here, and now I've solved the problem. I have my number answer, 43, and pizzas is my label answer. Now I need to check my number answer and label answer to make sure both of them make sense and to make sure they're reasonable. We always want students to check the answers to make sure they're reasonable. Here I'm dealing with whole numbers, so I know that when I'm adding, my sum's going to be greater than the two numbers or the two add-ins. The other thing I could do is do 43 minus 15 and regroup and know that that is going to give me 28, which is my other add-in. So we always can have different ways to check for reasonableness. So we know our number answer makes sense because 43 minus 15 is 28. So 43 pizzas is correct. And my label answer, pizzas, matches what I underlined here. Wonderful job solving this total problem with a missing total. So here is an example of student work of a completed Buccaneer problem. The example here is similar to the example I just modeled, where the missing information is our total. Students can write an X, we wrote a blank, either one will work. This problem says, Mr. Jones delivers packages. He delivered 26 packages on Thursday and 85 packages on Friday. How many more packages did he deliver on Friday? This is not a, this is a difference problem. So that's not right. So we're going to ignore that. Ignore this slide and we're going to keep it moving. We're just going to pretend that's not there. Now that you've solved a total problem with a missing total, let's take a look at another example total problem. In this example, I'm going to model how to solve a total problem with a missing part. So here we have our word problem. We always want to check for a table or a graph. I do not see a table or a graph here. If I did see a table or a graph, I would number it. But I'm going to write my attack strategy on the side right here to help me remember our steps. So our first U stands for understand by reading. Let's go ahead and read the problem. This says, together Dominic and Phoenix completed a 2,000-piece puzzle. If Dominic put 600 pieces together for the puzzle, how many pieces did Phoenix put together? We read our problem, I understand it, I'm going to check off that U. My second U is to underline the label and check for any irrelevant information. Again, I like to check my question sentence for my label. It says, how many pieces did Phoenix put together? I know that we're talking about pieces, so I'm going to underline that. Now I'm going to check for irrelevant information. I'm going to scan our problem for the numbers and make sure that all of our numbers are talking about or related to pieces and puzzles. So here, my first number is 2,000. Well, that says 2,000 piece puzzle, so that's related. And my next number is 600, and this says 600 pieces. I know that all my numbers are about my label, so I can check off my U. My first P is to parentheses needed numbers. So let's scan our numbers. Our first number is 2,000. That's related. So I'm going to put parentheses around 2,000. And again, I'm putting them around the number in the word. My next number is 600. So I'm going to put that in parentheses here. So I've parenthesed my needed numbers. Now I need to put 1s and 2s and maybe 3s above my numbers. We need to put our numbers in order. Here we know we only have 2 numbers. We are dealing with a single step problem. So I'm going to put 1 above both of these numbers to remind me that I'm dealing with a single step problem. I have put our numbers in order. Now I'm going to move to our S, which stands for schemas. Here we know we have a total problem because we're putting parts together for a total. I know I have Dominic's pieces and I have Phoenix's pieces, and we're putting those together for a total together. So I know it's a total problem, and I know that I have 1 step. So just as I did on the previous example, I'm going to write a 1 and a T. I like to underline it to stay organized. So I have identified my schema. Again, it's the total schema because we're putting parts together for a total. Dominic's pieces and Phoenix's pieces, and we're putting those together. Now I can move to my second S, which stands for solve. And again, we're going to look at our large schema map version 1. I'm going to write my total equation. P1 plus P2 equals T. And now our second step is to find T. Now sometimes our total is given, sometimes it's missing. Let's look back at our story. It says, together Dominic and Phoenix completed a 2,000 piece puzzle. Now that doesn't mean that Dominic completed the puzzle by himself, and that doesn't mean that Phoenix completed the puzzle by herself. It means that Dominic and Phoenix completed the puzzle together. So the 2,000 is actually our total. This is an example where our total is provided. And I like to help students say, well, did Dominic complete the puzzle? No. Did Phoenix complete the puzzle? No. Dominic and Phoenix together completed the puzzle. So we know that our combined amount is given to us. So we're going to put that under the total. And again, just like to check off my number so I know I've used it. Now we know part 1, we could say it's Dominic or Phoenix. It doesn't really matter, but I'm going to say it's Dominic. And I know that Dominic has put 600 pieces together. So I'm going to put a check mark next to him. Dominic is part 1. I know Phoenix is part 2. I don't know how many pieces Phoenix put together. That's what the question is asking. How many pieces did Phoenix put together? So we're going to put a blank here. And then step 4 says write our signs. Again, always in a total problem, our signs are plus and equals or plus and the same as. Now, when we have a total problem with a missing part, we're going to subtract these numbers because we are dealing with whole numbers and our total is going to be greater than the other numbers. So what I'm going to do is line it up. Little squeaky, but we're going to make it work. Draw my lines in between my 1s and 10s, 10s and hundreds, hundreds and thousands. Here I know I'm subtracting because my total is a whole number. We're dealing with whole numbers, so we know our total is going to be greater. So 0 minus 0 is 0. 0 minus 0 is 0. I cannot do 0 minus 6, so I'm going to regroup. 10 minus 6 is 4. 1 minus 0 is 1. So I know that Phoenix put together 1,400 pieces. Now I'm not finished though. I need a number answer, but that number needs a label. We underline pieces in our question sentence, so I'm going to write pieces for my label. I'm checking off the S because I know I've solved the problem. Now I'm not finished. Now I need to check for reasonableness. So we could add 1,400 plus 600. That gives us 2,000. We know our number answer makes sense. There are many different ways to check for reasonableness, but we want students to get in the habit of checking their work. I know my number answer makes sense. Now I need to check my label. My label is pieces. That matches what we underline in our question sentence, so we know we're good to go. Wonderful job solving this total problem with a missing part. So before we look at an example of a total problem with more than 2 parts, let's look at an example of student work. Here we see the word problem. There are 230 third and fourth graders at the assembly. If there are 144 third graders, how many fourth graders are at the assembly? Here we have parts put together for a total, third graders and fourth graders, but we don't know one of the parts. So we can see here that the student used our UPS check squared attack strategy and solved for our missing part. And the student had 86 as our difference. 86 fourth graders is our answer here. So here's just an example of some student work in action. Let's now take a look at a total problem with 3 parts. Here we always want to check for a table or a graph. I don't see one. If I did see one, I would number it. So I'm going to go ahead and write my UPS check squared attack strategy letters on the side as a guide for me to work through the problem. So our first U stands for understand by reading. This says Samuel made $160 trimming the hedges and $105 cleaning his room. He also made $26 for folding laundry. How much money did Samuel make doing chores? I feel like I understood the problem. I'm going to put a check mark next to my first U. My second U stands for underline the label and make sure that we don't have any irrelevant information or check for irrelevant information. I always want to look in my question sentence. It says how much money did Samuel make during doing chores rather. So here I know my label is money. I like to put a $sign, or students could write dollars, but we want students to understand that we're not going to write 5 money as an answer. So I like to put the $sign underneath our label of money. Now we need to check our numbers to make sure they're relevant or related to money. Our first number is 160. That's about dollars, so we need that. Our next number is 105. That's about dollars, so we need that. And our third number is 26, again about dollars. We don't have any irrelevant information. We can check off that second U. Now we're going to move to the first P, which stands for parentheses needed numbers. We're going to put parentheses around the numbers that are related to our label. So let's scan our numbers. Our first number is 160. That's about dollars, so I'm going to need that. And I'm going to go all the way so that I put in parentheses the number and what the number is talking about. So we have trimming the hedges. Our next number is cleaning his room. So I have $105. Put that all in parentheses, and my last number is is 26. 26 for folding laundry. Again, I'm putting parentheses. Whoop. Blocked it off right there. I'm putting parentheses around my numbers as well as what our numbers are talking about. I've put parentheses around our needed numbers. I'm going to check that off. Now I can move to my next P, which stands for put our numbers in order. Here we're working on single step problems, so we're going to put a 1 above our numbers. Later in our program, students will be exposed to 2 and even 3 step problems. In those cases, we will add a 2 and potentially a 3 above the numbers. But here I know that I'm putting parts together. That's the only thing I'm doing. So I'm going to put a 1 above each of these numbers here. Check off my P. My first S stands for schemas. Here we're talking about total problems. And in total problems, we're putting parts together for a total. So let's read this to see if it's a total problem. It says Samuel made $160 trimming the hedges and $105 cleaning his room. He also made $26 for folding laundry. How much money did Samuel make doing chores? So here we have trimming the hedges, cleaning his room, and folding laundry. And we're putting all of that money together for a total. I know this is a total problem because I'm putting parts together. So because it's one step and a total, I'm going to write a 1 and a T, and I'm going to circle that to help me stay organized. I've completed that S step, so I'm going to put a check mark next to that and move on to my second S, which stands for solve. Again, I'm going to follow my poster. This problem is a little different than the last 2 that we talked about and I demonstrated. Here we don't have 2 parts, we have 3 parts. Trimming the hedges, cleaning the room, and folding laundry. So all we need to do is change our total equation to add a third part. So I'm going to write P1 plus P2 plus P3 is the same as T. If you want, you can put P3 first or after, it doesn't matter. Now what I'm going to do is move to step 2, find T. I don't know the total amount of money Samuel made doing chores. That's what we're looking for, so I'm going to put a blank underneath that T. Now I'm ready for step 3, find part 1 and part 2 and part 3. So I know our first part is trimming the hedges, that's 160, so I'm going to put that under part 1, check it off. Part 2 we said was cleaning the room, cleaning his room, 105, I'm going to check that off. And our third part was the money he made folding laundry. He made $26. I'm going to check that off. Now I can move to step 4, which is write the signs. Here we're going to write 2 plus signs and the same as our equal sign. Now I'm going to line these up vertically to help me keep track of my ones, tens, and hundreds places, and I can add. We know we add because our total is missing. Marker's a little squeaky, but we're making it through. So we're going to draw lines between our ones and tens and our tens and hundreds and circle our sign. I'm going to start in my ones column. 5 plus 6 is 11. I need to regroup. 6 plus 1 is 7 plus 2 is 9. And then in the hundreds column, I have 2. So my number answer is 291. But I'm not finished. Every number needs a buddy. Every number needs a label. So here we underline money. I'm not going to write 291 money. I'm going to write $291. Students also could do a dollar sign and write it like that. Now that I have solved, I can check off my S, but I'm not finished. My last step is to check our number answer and our label answer for reasonableness. Our number answer is 291. We know we could add these numbers again or subtract 200 minus 291 minus 26 minus 105 to get 160. Many ways to check this answer. But we know our number answer makes sense. We're dealing with whole numbers and our sum is going to be greater than our add-ins. Here our label dollars or money matches what we underline. So we know our label makes sense also. Great job solving this total problem with 3 parts. Now that we've demonstrated how to solve a total problem with 3 parts, let's look at a student work example where the student is solving the total problem with 3 parts. Here it says how many snow days were there in December, January, and February. Here you can see that the student has numbered the graph, our horizontal bar graph here. And here you can see that the student has plugged in our numbers. They put an X under the T. We also could put a blank. And the student has added the 3 numbers and had a number in our label answer. So here is an example of student work where we're solving for the missing total, but we have 3 parts. Now what I want to do is show you a quick video clip that now that we've talked about total problems, so you can see what it looks like when the student is working with the teacher to set up and solve a Buccaneer problem. As you watch this video, I want you to pay close attention to a few things. First, the student is correctly solving the single step total problem. The student is writing 1T on the side to know that it's a total problem with 1 step. We're writing our total equation. P1 plus P2 is the same as T. They're solving and finding that we know our total and one of the parts is missing. They are going through our steps on our UPS check squared poster, and then they are subtracting to find the missing part. So let's take a look at this example.
All right, Scarlett, let's go ahead and work on problem B. So what do we need to look for before we even read a word problem?
We need to look for
We check to see if there is a
bar
table or a graph. Sometimes bar graphs, right? But do we see one? Nope. If we saw one, we would need to number it. But you can go ahead and write your steps.
I know.
Just fit some tiny little S's in there, maybe.
I couldn't. There's something in the way.
That works. All right, what does that first U stand for?
Understand?
By reading. There are 230 third and fourth graders at the assembly. If there are 144 third graders, how many fourth graders are at the assembly? Do you feel like you understood the problem?
Yeah.
Alrighty. So now we need to underline the label. What is the label for this problem?
A total?
It's asking us, that's the schema. What is our label if it asks there are 144 third graders, how many fourth graders are at the assembly?
Fourth graders?
Yes, ma'am, good, because that's what we're trying to figure out. How many fourth graders are there? Wonderful. You can check off that U. Now let's put parentheses around rooted numbers. 230. Nice job, third and fourth graders. Great. And there's 144 what?
Third graders.
Third graders. Great, excellent. Go ahead and put a P, or cross off that P. And then do you think this is going to be a one-step problem?
Pretty much.
Yeah, there's only two numbers. Excellent. All right, so let's ask ourselves, are there parts put together into a total? Are there two amounts compared for a difference? So what do we think between those two?
Total?
Yeah, and what are the parts in this total problem, Scarlett?
The parts are the third and fourth graders.
Good, and so when we put those third and fourth graders combined, that's the total amount. Nice job. Alrighty, so now we can solve. So go ahead and write your total equation. Excellent. Now do we know the total?
No. We do.
Well, let's look at that first sentence. There are 230 third and fourth graders at the assembly. So what's the total number of third and fourth graders that are at the assembly?
230.
So where do we need to write 230 if that's the total?
On part one?
But we just called it the total, right?
Oh.
What does the T stand for?
The total?
The total. Good. So now go ahead and check off 230 because we used it. And now what can we put there instead of 230?
144?
Yeah, we can put those third graders. Do you need some help erasing it?
Yeah. Can we switch pencils?
Sure. Alright. So we know one of our parts and we want to figure out the other part. How do we put a blank underneath P1 if that's what we're trying to figure out? That works. Alright, so now how do we find that blank? What are we going to have to do?
We're going to have to go over it.
Okay, but what are we going to add or are we going to subtract to find the missing part?
We're going to have to add.
If we added 144 plus 240, our answer would be almost 400. If there's only 230 third and fourth graders, could we have four? So you're close here. We're going to subtract, you're right, but we're going to start with the total. So put 230 here.
Okay.
And then we're going to subtract the part that we know. So 230 minus 144. And here's how you know. You're going to think about a bunch of third graders and a bunch of fourth graders, right? And if you take all of the third graders away, who's going to be left in the assembly? All the fourth graders, right? So we're going to start with the total number of third and fourth graders and then subtract the third graders to figure out how many fourth graders would be left. Okay? So can we easily subtract 4 from 0? No, so what are you going to need to do? You're going to regroup. But we're going to regroup a 10 into 10 ones. So now there's only 2 10s. Good, and now how many ones are there? 10. Excellent.
4, 5, 6, 7, 8, 9, 10.
Good, so the difference is 6. Nice job. Now here can we easily subtract 4 from 2?
No.
Nope, so we're going to have to regroup again. This is where you're regrouping 100 into 10 tens. And now we have 12 tens. Good.
4, 5, 6, 7, 8, 9, 10, 11, 12.
Difference is
8.
You got it. Nice job. Okay. So how many fourth graders are there?
86.
86. Good. Now, does that make more sense? Would 86 plus 144 equal 230?
Yeah.
Yeah. So now find a spot for your number answer and your label answer. All right, now what do these check marks stand for? Check the number answer, check the label answer. Good. So if there's 86 fourth graders and 144 third graders, would there be 230 third and fourth graders?
Yeah.
Yes, ma'am. So your number answer and your label answer makes sense. Well done.
Thank you guys so much for watching that video and for watching this entire presentation. We here modeled how to set up and solve our total schema. We looked at total problems with a missing total, total problems with a missing part, as well as 3-part total problems. And these are all going to be featured in our multi-step word problem intervention with total, difference, change, and equal group schemas. I look forward to seeing you in another video, but I do want to take a second to thank the Institute of Education Sciences, Texas Education, and the Meadows Center for Preventing Educational Risk. Without their help and support, this work would not be possible. I'll see you in the next video.